Hello geometry students, welcome to the next edition of our notes titled 7.2 Proving Triangles Congruent, which these are proofs. If you think back to our previous proofs, they're algebraic proofs. These will be structured very similar to those. So we can get started. Before we get started though, I have a little bit of encouragement for you. This applies to what we're doing in math. This applies to every math class. This even applies to life. Alright, you ready?
What doesn't kill you makes you stronger. What doesn't kill you makes you brighter. What doesn't kill you makes you stronger.
Alright, and for those of you who don't particularly like Kelly Clarkson, you can find numerous songs who have those same type of lyrics. I think that they're good lyrics for life, good lyrics for what we do, like I said, here in math class, for other things that we do together. So at times that I feel like life is hard, which it does, I just kind of remember that same saying, whatever doesn't kill you does indeed make you stronger, usually. Alright, let's get started with our notes. Here we have a proof, like I said. Something is given to us, they give us some information, and they want us to make a couple steps ourselves and then prove something from that. Alright, what they give us is that AM is the perpendicular bisector of XY in this triangle down here. Alright, and they want us to prove that triangle AMX is congruent to triangle AMY. We can do that using our triangle congruent shortcuts, our triangle congruent patterns that we've done in the fast food factory in our previous notes. Alright, so we can take a look at what we're given. We always start with what we're given. When we write our proof here with the statements and reasons, we always start with what's given. Before we do that, I want to go to my triangle and mark what I'm actually given, and also find out my end goal so that I can go from step 1 to step 2 and so on and so forth. Right? So, if AM is the perpendicular bisector, let me start with the word perpendicular. We should know what that means. AM and XY then are perpendicular, they make a right angle. So it's a right angle on both sides. Okay? If it's also the bisector, you should know what bisector means as well. Bisector means to cut something in half. So AM is the perpendicular bisector of XY, then that means that this segment here is congruent to this segment here. Alright? There's one more thing I know from this triangle. Although it doesn't tell us in the given, I know that AM here is the same thing on both triangles, so AM is going to be congruent to AM as well. There we go. From that, I can see that going around my triangle, what we've already practiced, that this is a side, this is an angle, and this is a side. On the other triangle as well, side, angle, side. They both match up the same way, so these triangles are going to be congruent by side, angle, side. Okay? All we got to do then is go over here to my statements and write them out. Like I said, I always start with what's given. So number one, what's given? Number one, what's given is that AM is the perpendicular bisector. I'm going to do some abbreviations. Perpendicular bisector of XY. Okay? So start with what's given. A lot of times, and I will say this, a lot of times the given is even simpler than that. I'm starting with a challenging example just to make sure that we know how to do it. Like I said, a lot of times proofs are easier. They give you explicit information. Okay? What can I gain from that? If that's given, okay, I know that these two segments are congruent to each other. So I know that next, XM is congruent to YM. Well, why can I say that? Why, based on this, can I say that those two segments are congruent to each other? Well, that's just simply because the definition of bisector. Definition, DEF, of a bisector. A bisector cuts something in half, so if that's cut in half, then I know that each segment is congruent to each other. Okay? Number 3, the next thing I know, is that these two angles are right angles. Okay? Since they're perpendicular, I can say that. So I can say that angle XMA and angle YMA are right angles. Why can I say that? Why can I say they're right angles? Well, because definition of what perpendicular is. So definition, DEF, of perpendicular. I'm just going to draw a symbol for that as well. Remember, I'm trying to get pieces that are congruent. This segment's congruent to this segment, and these two right angles are congruent, so I have to write that. Number 4, angle XMA is congruent to angle YMA. Why can I say that? Why can I say they're congruent? Well, all right angles are congruent to each other. All right angles are congruent. So I have this side, I have this angle. Next I want to talk about this side right here. Number 5, I know that AM is congruent to AM. And why do I know that? We talked about this when we talked about our triangle congruence patterns. That I know that because it's the exact same piece in both triangles, and that's called the reflexive property. Reflexive property. Okay? We'll use that a lot. It's one that typically comes up often, and it's really easy to remember because if I would put a mirror right here down AM, if I put a mirror on there, it would reflect both sides into both triangles, so reflecting that side is congruent. Okay? So, here's what I have. Once I've written that proof, I have this is my side congruent, this is my angle congruent, and this is my side congruent. Now I can write that these triangles are congruent. So my last step in this proof, number 6, so I can put that triangle AMX is congruent to triangle AMY. Alright, I should have left myself a little more room here. I'm trying to fit all on one page, but if that goes on one line, it's a little bit easier, I think. Okay, so those two triangles now are congruent. Why are they congruent? What did I find? Well, just because of SAS, and there it is. Okay, so this proof, like I said, is a little bit challenging. It's a little bit of more steps, but I'm going to post a couple more proofs for you in this tutorial. Take a look at those, and then any proof that pops up after this video, you can watch that one too. You really can't watch too many of these, but you can use a proof with any one of our triangle congruence patterns. SSS, SAS, ASA, stuff like that, or even HL. And notice here as well that these triangles were right triangles, but we didn't use HL because the hypotenuse was not given congruent and one leg was not given congruent. Okay? Alright, like I said, watch the next video, and here's something else for you. Alright, so here's a little bit extra credit for you if you would like some. This will give you a 100 replacement grade of any daily grade in the grade book right now. So if you bring this to me at the beginning of our next class, show it to me completed and correct, I'll replace 100 in the grade book. Okay, it's given for this proof that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. So 1 and 2 are congruent, 3 and 4 are congruent. So I want you to prove to me that triangle BEN is congruent to triangle BAN. All right, so write it out. If you want to mark the triangle first, it might help do it exactly as I did it. And if you want to watch the next video in the tutorial to kind of give you some help, and then come back and do this proof and bring it to me, like I said, I will give you the extra credit. All right, guys, have a great day. I will see you when we see you.